Hello, welcome to another tutorial. In this tutorial we're going to be creating a finite state machine, and with it we will then create some traffic light kind of behavior. Okay, so here's a demonstration of the functionality. So we have this traffic light script attached to this sphere, and if we increase it above 5 we'll go to a green light, and then if we decrease it below 5 again we'll go to an orange light and then a red light, and we can change how long the orange light stays on for. So again we'll go green, and then it's gone on for a little bit longer here and then turns red again. Okay, so I've started a new scene. The first thing we'll do is create our light. So we'll go to the hierarchy window, so right click, go down to 3D object and select sphere. I'm going to right click on a transform component and select reset to set it back to 0, 0, 0. Then with the sphere selected in the hierarchy, I'll press F to focus on it. Okay, so the first thing we have to do is create our finite state machine base class, as well as create an interface for the actual states. So to do this, we'll create a new script by going to the project window and right-clicking on the assets folder, going to create and selecting C# script, and we will call this script Finite State Machine. Once you've created the script, open it in Visual Studio. Okay, so here's the script in Visual Studio. And what we're going to do is we're going to delete everything from this script. Okay, the next thing we're going to do is we're going to define a namespace that we write all of this code within, and the namespace is going to act like a container so that we can easily separate it from the rest of our code base, but also easily inherit it into the scripts that we need to use them within. So we can do that by first saying namespace, and then we follow it with the name of the namespace. So we'll call our namespace Finite State Machine, followed by a set of coding brackets. Okay, so with the namespace created, we can begin creating our base class for our state machine. Okay, so the first thing that we're going to do within our namespace is declare the interface that will contain the methods that our states need to implement. So we'll start with the public protection level, followed by the interface keyword, and we're going to call our interface iState, followed by a set of coding brackets. Every state that the state machine will use will need to implement 3 methods. Okay, so it'll need a void called onEnter with no parameters. It'll need another void called onUpdate, again with no parameters, and then it will need a last void called onExit and with no parameters. So the onEnter function will be called on the frame that a state is entered. The onUpdate will be called every frame that the state is currently being run, and the onExit function will be called on the frame that the state is about to finish executing. Okay, with that done, we can begin declaring the class for our actual state machine. So again, we'll start with the public protection level, followed with the class keyword, and we'll simply call this state machine, followed by a set of coding brackets. It doesn't need to inherit from anything. So our state machine will only need one variable, and it needs to keep track of what the current state is. So we'll create a public variable, which will be of the type iState, and we'll make this an auto property, and we'll call it current state, and it's an auto property, so capitalization applies to the name. And we'll say get, so we're publicly gettable, but we only want to be able to privately set the state. Okay, so after this we will begin by making the constructors. So we'll first create an empty constructor, so we'll make it public, call it state machine, followed by a set of parentheses, no parameters, and then an empty set of coding brackets. And we'll create another constructor, right, so that we can set a state immediately if we need to. So again, we'll make it public, and it's constructor, so we follow it with state machine, and then a set of parentheses. So in the parentheses, what we want to do is we want to take an state, so an iState, and we'll call it init state for initial state. And what we're going to do here is we'll leave a comment for now, but we'll say set state to initial state. Okay, and we'll replace that comment later with a call to a method that we will write in a second. Okay, so that's the constructors done, and we can use them and modify them however we need when we build a state machine, but what we've got should be fine for now. Next we need an update function or a tick function, which will be called every frame so that the state machine can actually execute. So underneath our second, actually I'll minimize these two constructors here. Right, and underneath our second constructor, we're going to create a public void, so it won't have a return type, this method, and we'll call it onUpdate, or you could just call it update if you wanted, followed with some parentheses and no parameters. So in the coding brackets for this method, we're just going to simply check if the current state has been set. So if current state is not equal to null, so we know we have a state then, in which case we also need to update the state that's currently being executed. So here we say current state, and this is where we call the update, the onUpdate method. Okay, so we're going to write a couple more methods for our state machine here. So underneath the onUpdate method, we're going to write a method responsible for actually setting the state and changing the states, right? So this is going to be a public void, and we'll call it setState. And in the parentheses, we're going to have one parameter, which is going to be an interface, the iState, and we'll call this parameter newState, just for clarity. Now, before we change the new state, we want to check to see if there is currently a state running, because if there is, we need to call the exit function so that the state can shut down if it needs to, and then we're free to change it, right? So we'll open an if statement, and in here we'll check if current state, and make sure, double check to see if it's not equal to null, because it's not equal to null, then it's executing something. And if it is, then we're going to call current state, and we're going to call the onExit function from it. So once that method's been called on the current state, we're free to change it over, because that state should have shut down properly. So here we'll say current state is equal to the new state parameter. And then after that, we need to call the initialization method for the new current state. So here we'll say current state dot on enter, which will call the initialization method for the state. So now that we've created this setState function too, we can go back up to our secondary constructor and replace our comment here. And what we're actually going to say is just simply call the setState method and pass it the initState parameter. Okay, so we can minimize that again. I'll minimize these other methods as well. Okay, so we need one last method here, and this one's a little bit strange. So because our state type is an interface rather than the data type, the states themselves, if we need to get them back as whatever data type they are, we need to create a function for that. So this method is going to utilize something called generics, where we kind of define like a placeholder name for a type, and we can place some constraints on that as well. And that way, the user or elsewhere in our code, we can pass in random types, and as long as they adhere to the constraints that we define, the method will execute fine. Okay, so this might be a little bit confusing, but try and follow along. So we're going to start by making this method public, and here we're going to simply put state type for now, and it won't recognize it because it doesn't currently exist. Now we're going to create the name for the function. Now we're going to call this function get current state as type, and we follow that first with a set of chevron brackets, which are the pointy greater than and less than arrows. And inside our chevron brackets, we're going to put state type, and that will make it recognized over here now, because in here is our placeholder type name essentially. Now after those chevron brackets, just like a regular function, we need our parentheses, and in there, if we had any parameters, we could pass them there. But this function doesn't actually need any parameters. It's just going to get the current state and return it as the appropriate type. After the parentheses here, what we do need to do is define the constraints for our generic type here. So after the parentheses, we're going to use the where keyword. Following that, what we're going to say is we're going to say where state type followed by a colon. And here we can define the rules around what state type can actually be. So we're going to put two things here. Okay, we're going to first put the class keyword. And that's basically saying that the state type that is being passed has to be a class. And then we're going to put iState as well. So the state type that's passed in as a data type here also will have to inherit or implement the abstract iState class. So then after that, we can follow it with our coding brackets. And here what we're going to do is we're going to say return current state as state type. Okay, and that's our generic method done. So the way this works is we pass in a data type here when we call it, and as long as it adheres to these rules, it's going to try and return current state as the data type that we pass between these brackets. Okay, with that done, we'll save, and then we'll head back to Unity. Okay, so I'm back in Unity now. What we're going to do is we're going to select our sphere, select Add Component, and I'm going to start typing traffic light as a script name. Select New Script, traffic light is the name I want it to have, and select Create and Add. Okay, so that component's been added to our sphere, so let's open it in Visual Studio. Okay, so the first thing we need to do before we can actually get started is right at the top of our script file here, we need to actually inherit from our Finite State Machine namespace that we created in order to access all of the data within that namespace. So at the top here, we'll say using Finite State Machine. Okie dokie, and with that done, now we can actually start creating our traffic light. So the first thing we're going to do is create a public integer variable, and we'll call this waiting cars and set it to 0 initially. And this is going to be the number of cars that controls how the traffic light changes color. Now to make this a bar in the inspector, above it we can use an attribute. So we open a set of square brackets at the top here, and the attribute we want is called range, and we follow that with a set of parentheses, and in here we put a minimum number, right? So we'll say the minimum can be 0 cars, and the maximum number, so we'll say the maximum can be 10 for us in this case, and then we can just save that. Now aside from that, we're going to need access to two components. First of all, we're going to need access to the mesh renderer in order to change the color of our material. So we make this an auto property. We'll say public mesh renderer, and we'll call this renderer. Again, making it an auto property. So we'll say publicly be able to get it, but then we only want to be able to set this privately. Now the reason I've made this an auto property is so that we can actually access it from within any states that we define, right? So aside from that, we actually need our finite state machine, and we need to, because it's not a mono behavior, we can't like get a reference to a component from a game object or anything. We actually need to construct an instance of our state machine. But first, let's create a variable to hold that reference. So this will be public. And what did we call it? I think it's a state machine, wasn't it? Yeah. And let's call this state machine, like so. And we want to be able to get this publicly, and again, only privately set it. Okay, so after that, and above the start function, we will inherit the awake function. So remembering that we're working within a mono behavior right now, the awake will be called before the start function. So it's best to set your component references as necessary before they actually get used by your code later on. So we'll do that in the awake function. So we're going to say renderer is equal to get component, followed by chevron brackets, and in here we're going to say mesh renderer, followed by an empty set of parentheses. Right, so the next thing we need to do is construct our state machine. So we access our state machine variable and we assign it with a single equal sign, and we need to assign it to a new finite state machine. So we've used the new keyword, and then we need to access the state machine constructor. So for this one, we're going to use the blank one, but we could potentially pass in a state and it will automatically, initialize with that state. But we'll leave it blank for now. Okay, so for now, I think we will leave that there. So let's minimize these methods. And what we're going to do now is we're going to create the base state for the traffic light states, essentially. So what we're going to do here is underneath our update function, but still within the traffic light class, we're going to create a nested abstract class. So it's nested because we're defining it within another class. But we're going to start with the public protection level. followed by the abstract keyword, because we're making an abstract class here, just a template class, not one that can actually be instantiated, just one that can be inherited from. So we follow abstract with the class keyword. Then we need to give our class a name. So we will call this traffic light state. And this is going to inherit from our iState interface. Now we're actually going to need something else. So above that class definition, but within our traffic light class definition, I'm going to create a public and then enum. Now an enum is sort of like a custom data type. It can be read as an integer or as a string. It's just essentially a list of labels, right? So let's call this traffic light ID and follow that with a set of coding brackets. And in here is where we put the values for our enum. So we can say green is equal to 0, orange is equal to 1, red is equal to 2. And now we can access all of those values through this enum type. So back within our traffic light state class, what we're going to do now is create a public variable, which is going to be of type traffic light ID. And we will call this ID in all caps, and this will be an auto property. So we'll say it can be publicly read, but privately set. Actually, we'll change from private, we'll say it's protected. So the protected protection level basically means that any class that inherits from this one is able to access, or in this case, set the value of this variable, but other classes that do not inherit from this class will not be able to set the value of this variable. Right, so after that, the next thing we need is a protected, and this is going to be a traffic light, and we'll call this instance. So this variable is going to keep track of the actual light that's controlling this state, and that way it will be able to access all of the public data of the light. Okay, so the next thing we need is a constructor for this class. So we say public traffic light state, followed by a set of parentheses. Now, we actually need to, when we create a state, we need to send an instance of the light, whatever light that's creating it, to the state so that it can track it. So this is going to be of type traffic light, the only parameter for the constructor. And let's call this instance with an underscore, right? Because it's different from our actual instance variable. Now within the constructor, what we want to do is we want to set this variable equal to whatever has been sent to the constructor. So that's being tracked in here. So here we're simply going to say instance and assign it with a single equal sign to the instance with an underscore that was passed to the constructor. Okay, so you can see that the iState interface that we're inheriting from is still throwing an error, and that's because we don't implement the abstract methods that we defined within the interface. So if I select up here, and then if we just press Alt-Enter to bring up the debug menu here, and then we say implement interface, press enter. You can see the error's gone now. And it's automatically generated the 3 functions that we need. We're going to change this just very slightly. What we're going to do is actually remove the exception that it automatically generates in each. And we're going to, in between the words public and void for each of them, we're going to put virtual. So what that does is it says that these methods can be overridden or extended by any classes that inherit this one. So that's our traffic light state class done. So now what we need to do is actually use this class, because this is only a template class. This is abstract, meaning we can't actually directly use this. We can only inherit from it. So let's minimize this. And then underneath, we're going to create a brand new class. So we'll say, and it'll be public, followed by the class keyword, and we'll call this green light. and it is going to inherit from our traffic light state class. And we've got some errors because we don't implement things that we need to. Okay, so we have an error by the name because we haven't created the necessary constructor, right? Because the class that we inherit from, this traffic light state, has a constructor, and that it only has one constructor. It doesn't have a blank one, so we can only construct this class through this constructor, and this constructor requires an instance to be passed. And what that means is that inheriting classes, they also need a constructor that will accept that instance and then pass it down back to the base class. So what we're going to do here is say public and green light, because we're building a constructor. And what we need here is just the same parameter as our traffic light state constructor. So I'll call that underscore instance, just like the base class. And then we can finish the method, the constructor, but that's still going to throw an error because we haven't actually passed it down to the base class at this stage, right? So after the parentheses here, we'll follow that with a colon. And then to pass the parameter directly down to the base class, we say base to access the base class, followed by a set of parentheses, and we pass it underscore instance. And once we do that, you can see that the errors have gone. Now, the other thing that we should probably do in the constructor is set the value of our ID property. So we'll say ID is equal to traffic light ID dot green, and that is how you access a particular value within an enum. Okay, so what we'll do after that is we need to override our enter, update, and exit functions. So we can say public and then override, and if you're using Visual Studio, it will automatically tell you what functions you can override. So in this case, we'll do onEnter first. So what this base.onEnter function means is it's trying to call the base definition of onEnter, which of course is in our traffic light state, and it actually doesn't do anything. So we can ignore the base definition of it by removing that. Now when we enter the state, there's one thing we need to do, but we're going to do two things here. So the thing we need to do is change the color of our renderer's material. This is where that instance variable comes in handy. So we're going to say instance, and remember instance is of type traffic light, and traffic light has these public properties that we can access. So in this case we want to access the renderer, so we'll say instance.renderer. Then we want to access the material on it, so we say .material. Then we want to access the color of that material, so we say .color. And we want to set that, so we follow that with a single equal sign. And we can access the color class by typing color with a capital C. And then it's got a preset for green that we can use. Now after that, the extra thing that we're going to do is just do a debug.log to print a message to the Unity console. And in here, as a string, we'll just write the light has turned green, and then close that off. Okay, so the next thing we're going to do is we'll override the update. So public override on update, and we want to ignore the base definition. And here we're just going to do a debug.log, and we'll say the light is currently green. After that, we want to override our last method, which is the onExit method. And in here, we'll say debug.log, and we'll say the light is no longer green, because if the onExit method is called, then we know that the state is being exited. Okay, so what we can do now is actually just highlight that entire class, right? And I'm going to Control C to copy it, and we'll minimize it as well actually. And then underneath that, we'll just Control V, and we'll rename the name of our class here to orange light. And of course that also means we need to ensure that our constructor has the same name. So I'll just copy and paste that. So our constructor is now called orange light. And now we just basically want to turn where it says green to orange. So our ID will be orange. These strings will all say orange. But the color here, now there isn't an orange preset, so we'll just use yellow instead. Okay, so we need one more class, so I'll highlight that one, control copy, minimize it, paste it back in, and our last state is going to be called red light. Make sure the constructor matches, change the ID to red, change the color to red, and change our strings to say red as well. Okay, so quickly going back to our orange light. Okay, so in our orange light, let's actually create the timer functionality. So we're going to need a couple of variables within this state, and the other states don't need to know about them, it's just this one state that needs them. So we're going to create a public float, and we'll call this time and give it a default value of 3. Then we'll create a private float, call it timer, and give it a default value of 0. So we'll move down to the update function here. Now, as the orange light ticks every frame, what we want to do is we want to increment our timer. So we can say timer plus equals, and then we say time.delta time to add the time it takes from each frame, and we'll compile that all up. Then after that, we want to open an if statement, and we want to check to see if our timer is larger than the time that we've set, which is our time to wait for. And if it is, then we'll write a comment here for now and just say set state to red light. Okay, so we'll scroll back up to our state machine and let's open the start function. So in the start function, what we want to do is after all the necessary components have been created, we want our traffic light to go to the red light or to start in the red light. So what we're going to do here is we're going to say state machine dot set state, and then we need to pass it a new instance of a red light. So we say new, and then we need to use the red light constructor. So we say red light, followed by a set of parentheses. And the traffic light states require an instance, which is of type traffic light, which we are actually writing this within right now. So we can simply say this, because we are in that at the moment. So that's an example of how you would set the state from within, an object that has a finite state machine. But what about changing the state of the machine from within a state itself? Let's scroll back down to the orange light, and over our comment here, we will write the following. So we'll get access to our instance variable, which of course gives us access to the traffic light instance. Then what we want to do is say get access to the state machine, because that's the thing that controls the execution of the states. Then we can access our set state function, and just like we did before, we say new, and when we're in orange we're going to red, so this is going to be a red light. And we can't say this when we are trying to pass an instance of the traffic light, because we are currently working within orange light, and orange light isn't a traffic light. But our instance variable here is a traffic light, and it obviously stores a reference to the one that's controlling this state. So we will just pass it the instance variable as the parameter. Okay, so now our light will go to the red light by default. If we manage to get into the orange light, it will go into red after a certain time. But we need to add the rest of the functionality for the light, and that is all going to be done within our finite state machine update function. Okay, so the first thing we're going to do is open an if statement. And the condition for this will be if our waiting cars variable is equal to 0. So if there are no waiting cars, right, we're going to check to see if this light is set to green. And if it is, we'll set it to orange, so that potentially there's cars going the other direction at a set of traffic lights. So if this set of lights is green, we want to set it to orange if there are no cars currently waiting. So what we need to do is we need to check the ID of the current state to see if it's equal to green, right? And this is where our generic method comes in handy. So we'll open an if statement here. And what we're going to check here is we're going to say if our state machine, and we're going to use the get current state as type variable followed by a set of chevron brackets. So in here we put the data type that we want to receive our current state back as. So in this case we're going to put traffic light state because that data type is the one that has the ID variable in it. So we then follow that with an empty set of parentheses outside of the chevron brackets. Then we can access our ID variable. So we'll say .id, and we want to compare this against traffic light ID .green. So that will return true if the current state is, if the ID of the current state is set to green. And if it is, we are going to set our state. So we'll say state machine dot set state new orange light, and then we'll pass it this because we're working back within the traffic light class. Right, so that will change our light to orange, and then the orange light state will change it to red after the timer. So let me scroll down a bit. So now we're going to add an else statement to counter our waiting cars equals 0 statement. So we'll write else if, and here we're going to see if waiting cars is greater than or equal to, say, 5. And if it is, what we want to do is check to see if we are currently not in a green light, right? And if we are, we're going to swap back to a green light. So we'll open an if statement, and just like before, we have to check the ID of our current state. So we'll say state machine dot get current state as type traffic light state dot ID. And here we're just going to say if it's not equal to traffic light ID dot green. So in this case, if we're not at a green light, then we want to change back to a green light so that we can let all the waiting cars through. So we'll say state machine dot set state new green light this. Right, now we've nearly got everything, but of course there's nothing actually running each state because at the moment we don't update our state machine. So underneath our else if statement, we're going to say state machine and then just call the on update function, which will execute it every frame. Okay, with that done, let's give it a go and see what happens. So we'll save that script and then go back into Unity. Okay, so I'm back in Unity. So first of all, I'll select my sphere and make sure that we've got our waiting cars variable, which we do. So let's hit play. Okay, so if we open our console, we can see that we have instantly gone to the red light. So let's drag up our waiting cars variable here. And we can see that we've gone above the threshold of 5 and it's changed to green. And if we bring it back down to 0, it turns yellow and then turns red after a certain amount of time. So we've got that working. But what if we want to be able to control the timing of our orange light from the Unity inspector? Well, let's head back over to Visual Studio. Okay, well, the first thing that we have to do is make our orange light class actually visible to the Unity inspector. So above the beginning of our orange light class definition, we will open the square brackets. So here we input system followed by .serializable, and then we save that. And with that, the orange light class will now be visible in the Unity inspector, say if we create a variable of that type. So let's actually go and do that. So at the very top of the class, underneath our waiting cars variable, I'm going to create a public orange light, and I'll just call it orange light. I'll save that and go back into Unity. Okay, so I'm back in Unity now. I've got my sphere selected. You can see in my traffic light script, we now have this orange light variable, and if we drop it down, we can see the properties within that class. So we just have the public time variable at this stage. But right now, it won't actually do anything because we haven't hooked it up to the rest of our code. So let's go back to Visual Studio. Okay, so remember that our orange light data type inherits from the traffic light state data type, and that requires an instance which is passed down through the constructors. So what we actually need to do here in order to be able to use it is in the awake function, we need to basically reassign it to an instance of the orange light that has that instance reference. So underneath state machine, we'll say orange light is going to be equal to a new orange light And in here, we just say this. Then the next thing we need to do is in our update function, where we change to a new orange light if there are no waiting cars. Instead of setting the state to a brand new instance of the orange light class, we have one stored in our orange light variable after the awake function, so we can just pass orange light. So if we save that and go back into Unity, oh, actually, I just thought of something that we've missed out. We need to come back down to our orange light class, and in the onEnter function, what we're going to do is, at the very first thing in the onEnter function for the orange light class, we're going to say timer is equal to 0, just so that the timer resets every time we re-enter the orange light state. With that done, let's save that with Control S and then head back into Unity. Okay, so I'm back in Unity. We can see that our time is set to 3. Let's hit play and see what happens. Okay, so we're currently in the red light, so if we go to green and then come back into 0, it should be yellow for 3 seconds. Yep, cool. Let's change it to 1 and see if that still works. So changing to green, let's change it back. Yep, that was a lot quicker. But yeah, so there you go. So there's a very simple little traffic light that we've created using a finite state machine. So that's it for this tutorial, guys. I hope you enjoyed that and found it useful. You can use this finite state machine for, taught my students AI with it, and you can use it for a lot of other stuff as well, buttons and whatnot. But yeah, if you enjoyed this tutorial, please feel free to leave a comment, give this video a like, and subscribe to my channel if you enjoy my videos, and to see more content like this in the future. Thanks for watching, guys. Peace out.